Okay, welcome back everybody. We are going to work on project 2.1, read the button. And so, the description, the common table lamp uses LED lights and buttons, this is by today's standards, which can control the light on and off by pressing a button. Until a long time, not too long ago, lamps operated on AC. So, LEDs need DC. It's a very low voltage. You can't feed 120 volts AC into an LED. It'll just blow it up. But what that means is older lamps that just use two wires, to light a light bulb and AC voltage, just like the lights in the ceiling, right? In your ceiling fan, for example. That AC has to be regulated and rectified down into DC before it can be used by an LED. So every one of those little LED light bulbs, for example, that are popular now, those will take AC, but inside that light bulb is circuitry that regulates and rectifies that AC voltage down to a DC voltage so that the LEDs and the lights can stand it, because LEDs will not take 120 volts AC. It's kind of important to know. So a table lamp at home probably uses LED lights by today's standards, but they did not always. And it wasn't too long ago. Okay. We'll work to read the status values of the button and display it on the serial monitor. That's cool. So as to see it intuitively. So our button principle. The button is a digital sensor, so a button is a sensor which can read only a 1 or a 0. That means it's binary, only 1 or 0. When the module is not pressed, it is in a high level state, and that is 1. And when it is pressed, it is in a low level state, which is 0. Pins of the button are 16 and 27. Button 1, button 2. So here it talks about singular, over here it talks about plural, right? And this is our test code. We're going to define button 1 at pin 16, define button 2 at pin 27, and then our setup method doesn't return anything. There's no return here. This could be an integer, depending on what it's supposed to do. This could be an integer. This could be a string. It could return a sentence, characters. It could return a number, but we don't need it to return anything. So that's why it says void. Setup is the name of the method. Okay. And so this method is just going to run serial.begin 9600. That looks like a baud rate. I'm guessing when the serial starts up, it wants to initialize at a 9600 baud rate. That's my guess. Pin mode, button 1 is going to be an input. If you remember, the light was an output, right? And pin mode button 2 is also an input. And then after the setup initializes, then we go into our loop, and we have a Boolean. We have a Boolean. We're establishing a Boolean, right? And we're calling it button 1 value. And that is going to be set to read a digital signal from button 1. So this button 1 value is going to change as the state of button 1 changes. And we establish another Boolean, and we call it, and this is the same thing as up here, it's just a type, right? Like, this could return a Boolean to us, a 1 or a 0 if we wanted it to, but we don't. It's going to just read it to the display. So we're going to establish another Boolean, and we're calling it button value 2. It's a variable, and the type of the variable is a Boolean. And we're going to set that value to digital read the value of button 2. So we're setting this value to a method, and inside that method is overloaded with button 2. That's what we want. Could we also write Could we also write Boolean button2 value equals button2? Possibly, but this digital read is giving another command to, it's saying to read the value of this as digital, as a 1 or a 0. And why does it do that? Because we're feeding it into a Boolean which can only be a 1 or a 0. Whereas the value of button2 can be the value of button2 itself, right? Up here is btn2. That only represents like the pin mode. So see, we call this, we defined button2 on pin 27. So that's hardware. That's hardware. That's hardware. So we're reading the value of this hardware, and it's digital, so it's got to be a 1 or a 0. So I don't know if there's an analog read. We'll find out later. But if this were an analog read, for example, analog can be outside of 1 and 0. So that might throw an exception. If we were trying to pull in an analog number with a higher value than 0 or 1, and we're trying to feed it into a Boolean. So then serial print is going to send that signal, button1 equals, and then serial print is going to print button1 value, and then serial print is going to print some space, and then it's going to serial print button2 equals serial print button2 value in the delay. And this is going to loop, so I guess every 100 milliseconds, pretty frequently, it's going to update the status of this button. Is really all it's going to change. Now, this serial is probably going to show up in the console because we have not yet connected the display. So anybody, if you think it's going to show up on the display itself, like this thing, that would likely be mistaken. It's okay though. So let's set up our methods here, make it look clean. Okay, let's put that in there. Oops. That goes up there. Okay, so that looks good. And then I'm going to indent these up here too to make them easier to read. If you're accustomed to coding, you know what I'm doing. If you don't know why I'm doing this, you'll learn as you continue coding. Okay, so now we're going to press upload, and this is our output console, so we should be able to see. Okay. And nothing on the display. Where does the serial print to? Serial. I don't see like anything really happening. So let's look at what's happened in the console. Sketch uses 29 program storage space. That's fine. Connected features. Oh, so this is our ESP32 and our chip type. These are the features: Wi-Fi, Bluetooth, dual core, 240 megahertz. That's our speed. Calibration, fuse, coding, crystal frequency, 40 megahertz, and a MAC address. That's cool. Uploading, finisher, change baud rate. Changing baud rate to 921,600. Interesting. Okay. Flash will be erased from. These look like registries, like registers. These look like machine language, assembly language, where everything is just like hexadecimal is a step above ones and zeros. Everything's in hexadecimal. So we're writing. Okay, so these refer to those up there. Okay. So, oops. Try and pull this back down here. How do I? Well, okay, so let's go back to our instructions real quick. And we say test the result. Open the serial monitor. Oh, fiddlesticks. That's over serial monitor. Okay. Right. And there's all of our presses. So you see, as I'm holding it down, button 1 is zeros while I'm holding it down. But this method is continuously updating. Technically, I should call it a function. And I know nobody really cares about this. I keep saying the word method because I really am accustomed to working in things like C# and stuff like that. But in JavaScript, for the most part, in general vanilla JavaScript, you would use the word function instead. And what is the difference? Glad you asked. A method is a function, but it's a type of function. And a method exists in a class or an object. And in C#, for example, or Java, there's always a main method. It always starts out void main method. There's always a main method. So everything exists within that. Everything in the script exists within the main method. That means that every function that exists inside that main method is called a method. Now, converse to out here, what you see is this is a function. Now, this is our setup function, but it's a function because it's not part of a class. It's not part of an object. It's not part of anything. It's by itself. So, and this is a function. So I do use those words kind of interchangeably, but there is a use case. What are we looking at here? So that was kind of rambling a bit, but back to what you see, we're pressing our button 2 there, and we're going from 1 to 0. Now what can we do? This serial print is supposed to put more spaces in here. Watch this. So now we're going to go ahead and upload this. And what we're going to see down here in the console after we run, get the serial monitor back open. Okay, now you see how we have more space between here because we adjusted this. We put white space in here. And since it's between the quotes, it didn't get eaten up. For example, this white space up here, it's going to get ignored, but this white space is in quotes, so it won't get ignored. And that white space got transferred down here to put space in between button 1 and 2. Can we push them both at the same time? Yes, we can. Doesn't matter. Okay. Yep, so that's our buttons. Now, what have we done so far? In the one exercises, we did outputs. And in these exercises, the project 2 exercises with the buttons, we're doing inputs. Right? So outputs are things like LEDs, buzzers, motors. A motor is an output device. Input devices are things like sensors, buttons, RFID takes an input, motion detector takes an input, and those control the outputs. So anyway, I'm just kind of rambling about stuff, but yeah, this is a success. This is how this is going to work. And next video we're going to do the table lamp. So thank you for joining us today, and we'll make it to the next video.